department manager. And we will have a lot of very valuable speakers. You also see them on your monitors. All of them are experts in their fields, professors.
Tek tek yine sahneye davet etmek istiyorum. Öncelikle Profesör Doktor Sayın Fahrettin Öztürk, kendisi TEİ Yönetim Kurulu Başkanı. Buyurun efendim. Hoş geldiniz. Evet değerli konuklarımız, ikinci panelistimiz Profesör Doktor Sayın Burcu Özsoy, kendisi TÜBİTAK Marmara Araştırma Merkezi Başkanı. Hoş geldiniz.
Head of the TÜBİTAK Marmara Research Center. The third speaker is Professor Dr. Ahmet Turan Özdemir, Aspilsan General Manager. Welcome. And esteemed guests, our final panelist, Professor Dr. Mehmet Kul, Director of Sivas Science and Technology University. Moderator, now the floor is yours. I wish everyone a good panel. Thank you very much. And the
Değerli konuklar, hanımefendiler, beyefendiler, Saha Expo 2026 kapsamında düzenlenen kritik ham maddeler ve stratejik tedarik zinciri yönetimi konulu panelimize hepiniz hoş geldiniz. Esasen bugün burada savunma sanayimizin teknolojik egemenlik sınırlarından birini konuşuyor olacağız. Hafızalarımızı tazelersek, pandemi süreciyle birlikte küresel lojistik hatları, ardından gelen Rusya-Ukrayna savaşı ile birlikte dünyanın en büyük titanyum rotalarının kapanması ve son dönemde yaşanan bölgesel krizler bize bir acı gerçeği gösterdi. Artık savaşlar sadece cephede değil, üretim
access to raw materials. Thousands of ammunition consumed in a night and a nickel alloy that cannot be attained back in a single day can be replaced not through budgets or technology, but through access and processing that raw material. When we look at the most recent developments, we see that the demand for rare earth materials has increased, which is based mostly for batteries and wind turbines, but also the sensors and electronics intensity of the defense industry increases, leading to an increase in that demand. And unfortunately, with that increasing demand all over the world, the number of countries that own these rare earth minerals in the world are very few, mostly localized in a few regions, and export license restrictions are used as a foreign policy instrument by states. So supply chain management doesn't mean only finding the right part at the right price or keeping stocks or reducing stock costs. We know it from experience now. Because recently, due to the global crises that we've experienced, the Toyota models and the stable world model has now fallen apart. And now we will be talking about how we'll be able to construct a safer, more secure path for ourselves. And the panelists we are with here today are names that finish the framework of this from one end to other, from the minerals to the product. So I'd like to introduce them to you now. Combining their academic vision with the hardest parts of manufacturing, TEİ CEO, Professor Dr. Fahrettin Öztürk. Our other valuable guest is working for the raw material independence of our industry, working on test processes and localization, the leader of TÜBİTAK MAM, Marmara Research Center, Burcu Özsoy. And up next, our other panelist will be Ahmet Turan Özdemir, known especially for his works in the academy. No, Professor Dr. Mehmet Kul, I'm sorry, I got the order wrong. And our final guest, the general manager of Aspilsan, working to free us from foreign independence in battery technologies in our defense industry, Aspilsan general manager, Professor Dr. Ahmet Duran Özdemir. Before I move on to our panelists, I would like to draw out the framework. We have three main topics we'll be focusing on today. First, we will be looking at the baseline of where we are right now, and then we will look at the fragility of the supply chain globally and what the measures taken are and the activities are. And finally, we will have some strategic recommendations for Turkey and its strategic vision. And at the end of our panel, we will also have a Q&A session. So to abide by our time limit, I would like to ask you to limit your responses to 5 minutes. My first question is for Fahrettin Hoca. So, in the existing situation in the defense industry, from raw material to platform, how do you define the value chain? And what are the most important and most fragile aspects of this supply chain, of this value chain? Esteemed moderators and participants, I cordially salute each and every one of you. Welcome. It's an important topic this year, and the coming years will be the mass production years for the Turkish defense industry. For long years, we've been working on prototypes and development. And of course, here as TUSAŞ, for many years, we have had two TUSAŞs, both THY, Turkish Airlines, and the Ankara HQ. For over a quarter a century, we've been doing this. So we've been working on how these work, starting from raw materials all the way to the end product, with the things we do, the difficulties we face. And what the difficulties we face now are, as someone who is at the head of the people doing this, I'll try to answer these questions. Now, Turkey is taking a lot of important steps about a lot of things, about localization, nationalization, technological development, technology transfer, and of course here the components and products or the planes, because we produce both detailed parts, the components and parts, and we create products. So we are both the OEM and the supplier as TUSAŞ. So both of these TUSAŞs do that. And one of the most important problems we have here is that at the end of the day, we take the raw materials, process them. Sometimes we have sub-products, sometimes we have the end product. And what are the problems here? The first problem is that we're dependent, foreign dependent, and for a lot of parts, both in terms of production, domestic production, and our underground resources, there is a problem, but it's not unique to us. Many countries in the world experience these problems. If you don't have a wealth of rare materials, then you don't have some things like minerals, and you have to supply yourself with these somehow. You can develop partnerships, mutual projects, you can buy raw materials, but that's a separate category. What we focus on is taking the material that's already processed, and we work with that. And what we do is, well, we have a foreign dependency problem. We need to solve that. And the chair just mentioned that stocking, from what we know, is not a good thing. But the material conditions of today have brought us to a different point. The second topic is also an important point, which is certification, qualification. And these processes are quite long. And as we carry these processes out, we have problems regarding human resources and infrastructure. We also need to keep that in mind. And the third issue, which I think is the most important, is to establish a strong ecosystem. Now, I don't want to use negative perspectives a lot about the ecosystem, for example, because we're developing really quickly. I don't want to hurt our motivation, but our ecosystem is really strong. For example, in Turkey, we are working with around 1,000 companies as TUSAŞ, and we're working very intensively with over 250 of them. But one of the most important things to be done here is to make the ecosystem even stronger. The current ecosystem isn't enough to subsist us when we do high-level mass production. We need to work for that, but the process is not as easily done as it is being said. So, improving infrastructure and accumulating knowledge and technology transfer, you need to train human resources. And the most important issue is that, and the third important issue is the issue of finance. At the end of the day, you can want to do everything, but at the end of the day, you have a budget, you don't have endless resources. We have to keep that in mind, and when we look at it in that sense, the existing ecosystem needs to be made stronger. So as a company, we shouldn't be growing as a company. We need to grow with our ecosystem all together, with our infrastructure, with our SMEs, not just middle-sized enterprises. And we need to carry them to a further league, to a further level. And we need to do it step by step, gradually. So this is how we are looking basically right now. Thank you. Thank you. And of course, he is the owner of a platform and a system, so he gave us his feedback on the ecosystem. Now I would like to ask Burcu about the TÜBİTAK Marmara Research Center. So where do you see critical raw materials with regards to independence, and how would you position them in the ecosystem drawn out by Fahrettin? Thank you very much, distinct participants. Hello. The TÜBİTAK MRC was the first research center established under TÜBİTAK, and now we are working in different branches, also in defense, with our different various departments. Apart from that, the TÜBİTAK MRC also has departments on energy technologies, chemical and material processing technologies, of which I'm the vice president, and also we have the climate sciences. So we are working on a variety of different fields. And Mr. Öztürk said very well, the recipe for independence and strategic autonomy. The MRC is basically a kitchen for those goals. And I would also like to underline that, because in that sense, we're not just a research center, but we are a center that works on national technologies as a lab to reduce our foreign dependency. So in that sense, independently of the procurement of a raw material, the purity of the raw material and the process with which it was produced, and the microstructure and performance it has, all play a role in the definition of our local and national efforts. And the MRC is strong in a lot of fields like material science, chemistry and chemical processes, metallurgy, energy, defense and aerospace. Basically, to give you some examples, especially in the sense that, as I just mentioned, in the stages where we meet the needs in that framework, we have the jet engines, and we have an export permit that we use in the hottest parts of those engines, and we produce those super alloys using local and national means in the MRC, and also the advanced material recipes used in planes have also been fully nationalized and localized, which means that the core of an engine is written and put on R&B using Turkish engineers. And as for separation technology, we can convert raw minerals into processed metals, which is really hard. But as our research center, we have the necessary chemical processes developed locally for those processes, and we are not just the extractor of the raw material, but we also turn it into process added value. And within this scope, we also need to look at another thing, which, especially in developing common R&D projects, licensing and technology transfer, service demand, service requests, and these are all included in our work. We have a valuable, worthy position. And we also have our professor here with us. We also have a lot of great partnerships and joint efforts with universities, especially technology preparation levels 1, 2, and 3 carried out in universities, and in stage 4 we deliver them to the industrialists. And throughout that whole process we manufacture the pilot products, prepare the recipes, and carry out the entire mechanism and also coordinate it through all the way through to the delivery to the industrialist. Thank you. Thank you, Burcu Hocam. And now, Ahmet Hoca, in battery technologies, raw material monopolization is a global fact now, and Aspilsan's products and strategy, what would you say about that within this context? Esteemed guests, dear panelists and chair, I wish you all a great day. I tend to say in my speeches that the oil of today is stored energy. Recently, as we've seen in the Iraq-Iran war, our petrol independency is at critical levels, and we need to get independent, but no matter whatever way we head towards, we get dependent on something else. In 1981, Aspilsan came up with the rechargeable nickel batteries. So the lithium adventure that the Chinese started in 2002, we started in 1981 with our water license, and today it's our 45th year. And in our region, there have been a lot of examples that made battery investments and failed, like Northvolt with $11 billion of investment. And in the story of Northvolt, in their interview in the Financial Times, the CEO said that the biggest problem was the factories being established without signing contracts. And as Turkey, we also now look at whether we can export things more than just doing it ourselves. So the things we do compete with the global standards. We don't have any problems with regards to quality. And the point is to manufacture it at the right cost and deliver it right. And so this is a matter of scale economies of scale right now. And we're a company that can manufacture lithium-ion batteries with different chemicals, and we are the only company that is growing in this field. And the places where we're competitive are Far Asia and China, of course. Now let's talk about critical raw materials. In Turkey, in 2021, we were reborn from our ashes thanks to our president's project-based incentives, and we established a facility of $60 million, and the raw materials that we produce from 6 different raw materials, we had to procure those raw materials from different sources. We imported them, and to break our dependency with China, we are continuing those activities with Korea, Japan, etc. But sometimes the costs go up eightfold. Nickel, magnesium, cobalt, silicone, graphite, and other such materials. To establish that independent supply chain in Turkey, we are in diligent efforts, because we are not just purely a commercial trade company. Our mission and our vision are to accomplish an independence for the Turkish defense industry and to solve the problems that are obstacles in that path. In that sense, industry-grade battery-grade foil production is something that we have accomplished. We're also working for copper foil. There are different materials, separators, tubes, conductors. And to create that, you need to have an economy. And our client wants Japanese quality batteries for Chinese prices. That's the equation. And we are supplying and feeding very valuable platforms, from Roketsan's Orca to their aerospace projects, from our 5th generation JetCons battery to whatever else you can imagine. We have secure critical batteries that we produce from the raw materials all the way to the battery itself. And Turkey also needs to establish an independent supply chain. And as Aspilsan, when we look at that independent supply chain, mining, active materials, electrode and battery, and systems production, and also recycling. So from raw material manufacturing to the end product, we do a lot of things. And for the independence in that regard in our country, we need investments that turn raw materials into active materials. We are supporting this. And how did China accomplish this? They met their own domestic needs and created an economy. And in our universities with TÜSAŞ, Roketsan, TÜBİTAK, and our sister companies, we are working to develop and expand that ecosystem from end to end. And the Turkish Armed Forces Reinforcement Association and the Presidency of Defense are also among our top and most important supporters. And with their supporters, we are working diligently to remove our dependence on raw material imports. We have so many things to talk about, but this is all I had to say for this round. Thank you. Thank you very much, Professor. Now we're turning to Mehmet Hoca, and we will be asking him about minerals and what is being done for minerals in universities. As for the production of critical raw materials, could you inform us on what you've been doing so far and their impacts on strategic supply chain management and their impacts? Thank you, esteemed moderator, dear panelists and guests. First of all, I would like to salute you all on behalf of Sivas Science and Technology University. Our university is a very young university. It's not very well renowned, so that's why I am underlining its name. We define ourselves as a new generation public university. Sound check. Does it work? Yes, it's working. So we define ourselves as a boutique new generation public university, and we have few faculties, few departments, few students, and qualified education for all of them. That's the point of the university. As for your question, what have we done? We are a very young university, but we are especially focused on the defense industry. 3D metal printers and aggregated manufacturing are very important both in the defense industry and in the civilian industry. There's a huge potential there. In 2020, in a market research, also we visited Fahrettin Hoca back then, and also a lot of top managers. And yes, metal printers were bought and actively being used, but the problem with the critical raw material was the powder metal, and a lot of these printers consume powder metals, SLM, and causes a bottleneck. So we saw that we needed to do something about this. So we established our digital alloys production center. We have a vacuum device there. So we're working to improve our alloys, because there can be problems in the procurement of alloys, supply of alloys, because there can be problems with that. So we create alloys from elements first, and then turn that alloy into powdered metal with Varviga, gutterization, etc. These are pilot facilities, so we established these facilities. And then there was a Tubitak project under which we had hybrid atomization. So, you know, molybdenum, tungsten, and other such metals with high melting points. And we also established a system to create powdered metal from those alloys with Tubitak. And these efforts are underway right now. We have manufactured some powdered metals, but we don't just develop. We also have sensitive cast capabilities from a cast. We have 6 mini jet rotors. This is a super alloy, not nickel L780. We cast it, and now we're seeing the initial results. And now we're carrying out the engine motor tests. These were requests we got from abroad. Another issue is ceramic printers. They're very new in the commercial life, and from what I know, in Turkey we were the first organization in Turkey to use ceramic printers, but their raw materials are also very expensive. You know, 1 or 1.5 kilograms costs a ton of money. Therefore, the raw materials of these also need to have their clay developed, and also they helped us with that. And this gives us better performance than its alternative with our printers. And of course it costs a tenth of what it would otherwise. Moving on to the next slide, let's look at what else we're doing. The battery technologies in storage is a critical issue, which is something we all agree on. And since we think that universities need to work on this, we also established a battery research center. So from chemical synthesis, from the stage of chemical synthesis to the production of the port rigid. So end to end, we established a pilot facility that would do all of this. This is quite recent. Hopefully, I will also make some other explanations about this. The Optic Perfection Research and Application Center in Sivas, we work in the optic field for day and night vision systems, but now we don't have any investments in thermal vision, so we're also going to close that gap. Aselsan Sivas, thermal camera optics design and their optoelectronical design and their manufacturing with all of their coatings, we made that investment. It is working quite actively right now, at full capacity perhaps. And as Fahrettin Hoca just said, we also need to train qualified human resources, both undergraduate students and graduate students and PhD students. We take them in as groups with 6, 7 or 2-month periods wherein we provide them with certain trainings. And one of the most recent training centers we opened is the IKI Training Center. Unfortunately, no facility in our country worked on that. And here we test rockets, static tests of rockets up to 1 kiloton. And we also have a vacuum room, and we have 65 kilometers of range that we test in this vacuum room. So for high altitude tests, we also have such an infrastructure. Moving on to the next slide.
Another expertise of our center is the rare earth elements. We didn't know about these elements much before this. Back in time, we didn't planned by the State Planning Center. We had a project for this in autumn mining faculty. research in this regard, and we took concentration of these elements, and later started the test of these elements. And with the solvent extractions for each element, we tried to make the purification process for each element. I mean, on the other hand, of course, there is another issue here. How we will achieve the next part of this project. There are some institutions that start these projects, but they are not able to finish and conclude all these projects. Sometimes I just suggest them which problems to be solved, which are more critical than the others. And on the other hand, the substances that we are having are really hard to process, but the substances in China are easier to process. For instance, through a magnetic process, they take the rare elements, and then they have much more than substances than we have. Then they later produce a concentration of 6%. And when we are trying to do this, we just reach an amount of 20%. And so I can say that our substances are hard to be processed. And going on the next slide, I could say that recently in Saha Istanbul organized a solid elements workshop in Gebze University, and we said that we need an annual 5 kilograms of elements for each year. So we need to make a supply for this. So of course we know that medium is a material to be processed difficult. Of course the method that Otsu pursued was different than this. So I can suggest that for these critical raw materials, based on the needs, focusing on the high concentration in a pilot facility, we can produce easy raw material. And later, the target is to be not separating all of the rare solid earth raw materials, but just to produce and make the supply chain available. And on the other hand, we can use regular conventional methods of production. We can start working on the regular separation methods, and we need to focus. We need to produce a focus based on the needs of the certain actors. On the other hand, during my master's degree studies, I worked on the germanium, Aselsan, and the many other companies working on these, and they are really having problems or supplying these germanium elements. Regarding this material, we came to a certain level. In the laboratory measurements, we have reached 125% of accomplishment. And in Kayseri University we did. In this university they separated some of these elements for us, and we used this amount for commercial processes. And we produced amount of 15% of germanium in that laboratory, which was located in Kayseri University. And later another company, US company, buy this. But on the other hand, in order to, after these 20% of concentration, we need to produce another form for this germanium. Later we need to have this induction process. We didn't do that. Of course we know that this is a hard process of work, and it's a difficult process for refination and I think this is another issue that we should handle as well. And what are the commercializing issues in terms of the R&D aspects? We know that we have some problems in this. Some of the R&D projects that are held by the academicians are really be eliminating, because there are no pilot systems for these to be remained, because in order to overcome the debt valley, we have to make investments for the facilities, pilot facilities. If you don't want to be, if you don't want our researchers to be destroyed in the laboratories and stay just to be staying there, we need to have pilot facilities, and we usually put a target of 4 supply chains. We never think about we will have a supply chain for these raw materials or not. I think during the project supporting processes, the academicians should be supported in this regard, and the academicians should also be mentioning about these issues in their projects. They should have some points specifying these issues. And on this technology part, we are like critical raw material hunters. I think I'm running on my... I have spent too much time for my speech. Thank you very much for giving me the word. So, we have finished the first part of our panel regarding the current situation in the sector. We worked on the GEMS substances which are worked on the universities, the processes, steps for the processing of these, the roadmaps, the prioritizing, were the feedbacks that we should be taking into account. And on the other hand, can you please speak about? Of course, you've also spoke about TÜBİTAK projects, the cooperation with TÜBİTAK, the achievements that we had, and on the industrial part, in the current situation, we can say that, especially regarding the raw materials, we are dependent to the international companies. You know, he mentioned that we need to produce a powerful ecosystem for these supply chains, and we need to enhance the certification process and the ecosystems for these systems. And on the other hand, in the Aspilsan, in the current situations, he mentioned that they are working on the new alternatives and they are working on the settlement projects. But however, the size economy is another aspect that we have encountered. On the second part of our panel, the fragility of the supply chains and the precautions that are taken in this regard. Of course, at the beginning of my speech, I also mentioned we have some geopolitical risks, and the pandemic has just shaken this process, just in case process. We have seen another model, and in this process, what do you think about this transition period, and how this affect this transition period, the aviation cost? Thank you very much for giving me the word, dear chairman, for this panel. Especially, I would like to refer to the İbni Haldun, geography is destiny. The geopolitical position of the country that we are located, the geography that we are living in, are defining at some point. And here we are also having many discussions in this regard, regarding stock protection. Sometimes I just give an anecdote, and never. Let's not compare Japanese and Turkish. Very often, they are really different cultures. The infrastructure you have, the geography, ecosystem, the universities, research centers, they are all united. You have to think about this in a holistic way. When you are making a decision, you have to think about this in an instant. So you cannot have an approach with minimum stock. So of course we have short-term raw materials, but and for these short-term raw materials you have to work with a certain amount of raw stock. So let's see the crisis in the world. We have a crisis in the Hormuz now. Some spare parts couldn't be delivered to our country. We took some of them, some raw materials. In case of a war, of course, you are having a problem, and you are always ending up in the second level because there are some prioritized countries. We had a pandemic, of course. This is the importance period of our life. It has changed many things in our life, and it showed that many things were so important. If in the supply chain we didn't have any problems, we couldn't understand the pandemic that much well. When you have a disruption in the life, you understand that some other thing cannot be happening. You know that we have seen this in our sector. We have seen that many of the sectors and industries were really fragile. Depending on just a single source was really a problem. We understood that, and for a long time we have been applying this, but we are trying to find at least 2 or 3 sources for us. They are having challenges in this regard. When you have a single source, if you have a production chain, you are having just problems. For instance, you have an X amount of production, but if any crisis occurs in any place of the world, you just encounter problems. For instance, if you are working with other countries regarding the systems, you just cannot reach them during a crisis. In these circumstances, what we can do? Of course, we are talking about the expense reductions. We need to care about the expenses cost. Of course, we need to think about the cost efficiency. I'm not thinking about this. I'm not saying this. Of course, we need to think more, and we need to produce cheaper. But in strategical aspects, we need to have a different approach. Of course, producing something in a cheap way cannot be the single target of us. Of course, our colleague has mentioned, we are talking about the Japanese quality, but you just want it with the price of Chinese product. Of course, you know that the Japanese production is more costly. The more you produce it, the more you adapt the new technologies, and plus the more but of course you can just have a good production process, and of course you need to find alternative sources as well. Of course, you should have a B plan all the time. This is really critical and essential. I don't want to talk about the names. I don't want to open any discussion, but I'm just always saying this. In these regards, I should just underline this. If you have a problem in a source, think about the third option. While I'm wrapping up my verse, I would like to talk about the settlement. Of course, replacement is an important point. Deployment, I mean. But while we are doing a deployment of the raw materials, is the requirements and the cost efficiency should not be ignored. You shouldn't just come up with a product that is produced by everyone. You shouldn't be in the scene with such an aspect, because this country doesn't have unlimited sources. We need to decide based on our capacities, and deployment of the sources is a really long-term process. Maybe the most important aspect of this is this strategical cooperation. You have to cooperate with the others, and coming into a certain point, you need to do the deployment afterwards. If you just try to do everything starting from scratch with no experience, no human sources, no infrastructure, test facilities, you cannot have deployment processes. You can do deployment, but you cannot make it sustainable. What is sustainable? Sustainability. Everyone here can produce something. Everyone can do that, of course. But tomorrow, I cannot see these people in the industry in the coming 20, 30 years. They may produce once, but we don't know if they are going to come once again or not. We need to have a good fiction, a good planning, and these fiction should be supported in every aspect of the serial production process. Thank you very much, Fahrettin Hoca. Burcu Hoca, I would like to proceed with you. In general, globally, strategical supply chain management is really fragile. We have spoken about this, and we are trying to apply supply process throughout this neighborhood countries. We are just trying to make a supply chain with the neighborhood in countries which have the common point of view with you. As to be talk, Mom, do you see what do you think about the powers which are using the raw materials as a weapon? What kind of early detection and warning system do you produce? When you think about this issue, regarding the critical products, you need to see that these are not limited to the certain countries. Technology, of course, is a really important point, and to be talk, Mom, we are trying to be really sensitive on this regard, especially as you mentioned the risk map. I would like to speak about it. You need to have you have to have researches on these risk assessments. We are really giving importance to these risk assessments process. Especially we have a database monitoring system, export dependency and risk analysis are done in this regard. And throughout this process, we try to apply a certain process of risk assessment. Of course, we mentioned about the human sources. Mom really has a huge potential of human resources, and in this regard, you need to scan the global literature. You need to keep track of the patent flows. Of course, the studies, research done by Tubitak Mom are really important in this regard. These are just trying to show the criticality level of these issues and predict the problems before they occur. These are really important, especially during the crisis periods. And Mr. Fahrettin Hoca mentioned B plans are really important. B plan receive. And we need to think about these B plans, and you need to think about the technological preparation processes starting from 1 to 9 rank. You need to take the recipe that is produced in the laboratory and then later turn these into the pilot projects and later just give this to the defense sector. Of course, we are working on the academical level, but during the literature scanning processes and the follow-up process for the patent flows also matters, but B plan is really essential in this regard. This is the approach that we are having in this regard. And lately, we have seen how important this is. As a center, we have seen this, especially the recycling, the regaining of the waste. These can be technological waste, electronic waste, industrial waste. These are really important. You should recycle these. As you mentioned, of course, we have elements as well. The regaining process is really important, and this is a fact that is empowering our hand. And I would like to mention shortly about the stock issue. You may have storage in your hands regarding the raw materials, but especially you need to you need to have the know-how process as well in order to protect these raw material aspects. Especially before we do our researches and works, we try to keep track on the things on the digital atmosphere and try to speed up the processes more and more. We try to finish all of these issues in the digital atmosphere first of all, and we try to predict all of the problems in this regard. Thank you very much, Burcu Hocam. Ahmet Hoca, I would like to ask you a question. Burcu Hoca mentioned about recycling. She gave some insights about this. In UA and USA, battery recycling is really issue. In order to overcome a second conventional raw material crisis, is it enough? What do you think about this? What do you think about these processes which are held in UA and EU?
Artık
As our professor mentioned, in Turkey we have many kind of mines, of course. In Chile, the purity of the lithium which are produced in Chile is different compared to Turkey. The labor force, the labor expenses that we use here is really costly. Of course, you are trying. This is not a sustainable thing, actually. These are kind of R&D works. Some countries in this regard are really lucky, and some are not lucky. We have many kinds of mines, of course, but regarding the purity, the cost efficiency is not really a point of advantage for us. Maybe for the bad day scenarios, we can evaluate these aspects. Of course, in the commercial aspect, I think that we don't have a sustainable commercial infrastructure in this regard. In USA, we see the same situation. Back in time, recently they have produced a strategy for 2040, and they forbid the sale of batteries to third countries. Of course, you are taking batteries, and they don't want these batteries to be sent to other countries, and they want to use these recycling afterwards. And in EU, in USA, we have seen the battery passport, as you mentioned before. As you can guess, EU is really sensitive in this regard. They are thinking about the child labors. They don't want to use the batteries that are produced in Congo or in many other African countries. They don't want to use child labor. Of course, on the other hand, we are seeing the terror that they cause in any other parts of the world. But the battery, this issue is in some respect is regarded the tracking of these batteries in order to make a qualified sale process for these countries is really it is really important to have a tracking system, and in order to produce a sustainable process in this regard, the raw material that are produced through the raw batteries, you need to save these raw materials, and in order to use these raw materials produced from the raw batteries, you need to have an economy which is qualified accordingly. And in order to of course, we are going to have some supporting point to steer the wheel as well, but today in these circumstances we don't have facilities or batteries to be used in this regard. Of course, I think that UA is going to step back in this regard. Of course, for instance, in Munich they don't use inner launch vehicles, and in Munich for 3 years the recycled materials is more costly compared to the raw materials now. It is quadruple more, especially when you think about this. It is not a sustainable economical situation, of course. In order for the critical platforms, we need to regain and recycle the batteries, and we need to have a roadmap in this regard. We have spoken with the ministries of our country, Ministry of Industry, Environment, and we are trying to provide them some inputs in this regard. And with the Ministry of Defense, of course, we have a battery workshop, and in that workshop we try to work on the compounds of the batteries and the recycling processes, and at the battery value chain is to be supported by the other aspects, of course. And in order to finish all of these regaining and recycling processes, we try to get in touch with the other institutions of our country. But today, for using the batteries and later separating and recycling them, and later the raw material. These raw materials that are produced throughout these raw materials should be used through our systems again. And this is another aspect that we give word. Thank you very much for giving me a portion to say my words in this regard.
Mehmet Hocam, bu konuyla ilgili
About this topic, we talked about a lot of problems and what the world is trying to do to solve these problems. We also talked about what we are doing. Now, precisely at this point, in the university industry partnership dimension, what are the steps being taken all over the world? Could you inform us about that? Thank you very much. Of course I can. Now, as a matter of fact, the geopolitical location of Turkey, and especially what's happening recently with Iran, Israel, and the USA, and Ukraine, Russia before that, and the pandemic, these all demonstrate that the security problem are the critical raw materials sometimes. And of course, as Fahrettin also said, it needs to be cost effective. The production needs to be cost effective, but at some points you can't ask for that. From what I know right now, with regards to germanium or tungsten went up 5 times recently, just the mineral itself. China restricted their minerals exports. So what is Roketsan to do now? What's TÜSAŞ, what's Tİ to do now? What are the industries that need such high heat alloys to do now? My suggestion for Turkey is that yes, it needs to be cost effective. Otherwise it will be pointless to produce, as the general manager said. But for these difficult times, we need to establish a pilot facility to use national, local materials. Of course, the minerals might not be as good. It might not be as economic, but if the industry is in a huge crisis, then we need to find a solution to this. So what are we doing globally for this? It's not a question of where we get the minerals from, but mineral enrichment, separation, purification, and alloys. All of these stages need to be considered, as have been the case in the world. For example, in the EU, there's the raw materials of the consortium on raw materials, with over 300 universities and companies. This materials ecosystem there's a system focused on this. And in the US, there are now alternative magnets developed for earth materials like nodium. But in their academic outputs, the industrial integration was also achieved through the system. China started from scratch and built all systems from the raw materials to the end products under state control, and they have their state care laboratory, the infrastructure that is required for them to do this work. So what do we need to do? TENMAG was established. So yes, we also have some work we're doing in this regard. We have TENMAG, we have TÜBİTAK MRC working diligently. There are a lot of projects being carried out on the TÜBİTAK side, and we have a data-driven system for commercialization. We need to establish those kinds of systems. Thank you. And that concludes the second part of our panel. So about what are the problems we see in the world, because it's a difficult balance. On the one hand, we need to reduce costs, but on the other hand, we also need to become independent in critical issues. And the best way to do that is to draw out the risk maps, like Burcu Özsoy said, and look at the priorities and strategically plan out everything, including perhaps cost. At the final stage of our panel, we have a question of the future vision and strategic suggestions for Turkey, which I will be asking to all of our speakers. This is a very result-driven question, and it's quite intertwined with what we've talked about so far. So the question basically is, what is required for our systems and platforms to work at the speed, quality, and amounts we want? What are the concrete steps we should take for that? Let's begin with Dr. Öztürk. Thank you. Now here, in different regards, we've discussed what we need to do. And as we define a system, we need to define it as a whole. When we say a system, it could start from the lowest level of training to mass production. All stakeholders involved. So this is what comprises the system. And so what kind of path should Turkey take here? Based on my experience so far, for example, when we're talking about deployment and competency, we need materials and process knowledge. Without that, you can't do anything. You have to attain this. This is the first step. And now the second step is to expand the supply ecosystem, and SMEs need to be involved in this system. For a strong ecosystem, this is necessary. Now, of course, we need to increase our resources. And when we say resources, we don't just mean the number of companies. We're also talking about the involvement of these companies, which requires two important points of support. One, financial support, and two, technological support. And technological support is provided here by MRC universities, our research centers. They also need to be very active in this, because a company that does mass manufacturing cannot follow this. They cannot have this depth of knowledge on that issue. And another important issue is universities. Universities have a lot they need to do. And levels 1 to 3 are developed there. It gradually goes up. So without universities, I say that without a strong university, without strong research centers, you cannot sustainably produce 5th or 6th level warplanes. You always need to have a complementary mechanism supporting the system. So, in the 5th generation, they attain the new technology. We need to be ahead of them. We need to have a system that constantly monitors these. And third, which is an important point, digitalization and artificial intelligence supply chain. So in artificial intelligence, we both need supply chains and artificial, and it needs to be traceable, and the risks need to be analyzed beforehand. And within this scope, all advantages that technology provides us with need to be used, not a decision mechanism. The mechanism that helps you decide. So AI will never be able to solve all your problems, or neither will digitalization. But if you use these effectively and well, then you will make faster progress. And in the defense industry, independence doesn't just mean producing, but also making it sustainable, which is a thing that matters. You can produce something once, which we've done dozens of times, and we need to understand this really well. Within this process, we need to establish an integrated planning mechanism. All institutions, all stakeholders need to work on the same roadmap. No diversions, because one of the biggest problems is diverging from our goals, heading in a different direction. But with a co-working culture, these processes can be accelerated, and we can have long-term agreements and alternatives to make progress. And financially, we need to work with our friendly and allied countries, have partnerships with them, and involve them in our products as clients or partners. And that huge financial burden needs to be met together with them. Thank you very much for your attention. Thank you, Mr. Öztürk. Now on to Ms. Özsoy. Thank you. Actually, I'd like to answer this on two different dimensions. First of all, we know that we need to be fast and we need to reach quality results. This is one stage. The second stage is to be ready for any interruptions. And so starting from the first stage, speed and quality, especially in strategic supply offices and a strategy, we need to create these to get faster and attain higher quality. This is critical. And also, as Mr. Öztürk also emphasized, with friendly and allied countries, and especially with countries who have materials that we can easily access, but even during the design of the material, we need to opt for those materials to be able to resolve any prospective problems, and especially being dependent, we also need we can also avoid difficult processes like preparing for a difficult alloy BOM. And there's also another thing I'd like to talk about: which raw material and which subsystem on which platform based on which performance criteria. To make all of these clear, we need platform-based critical materials breaking trees, which would be critical for us to achieve speed and quality. And on a pilot scale, these products also can be put forward. And in the case of any interruptions, which will be a difficult process, especially for materials that are highly critical and lowly supplyable, creating this supply would be like a guarantee or a warranty. And especially, as our general manager also mentioned, these recoveries, these waste being recycled in times of crisis, will be the most reliable source of raw materials. And of course, like Mr. Öztürk, I'd like to end my remarks talking about raw material trade with friendly countries. especially in these topics, the partnerships and efforts we carry out together, and processing partnerships directly from our minds are also things that we can do. Thank you very much. Thank you very much, Professor, General Manager. Recently in Aksungur UAV, we used the TIA's engine and Akbilsan's battery and went up to 40,000 feet. And in the Orca battery, we had submarine torpedo along with its battery. We developed a battery. And for the autonomous submarine project and our submarine projects, we signed a space protocol with Turksat and TUSAŞ. And again, for the walkie-talkie batteries of Aselsan 300, 600, other such platforms making batteries. These are what I can think of, but from weapon systems to ammunition, we work in a variety of different fields to produce mission-critical batteries. And when we push the torpedo button, whether it will hit the target or when we go flying with a plane, whether our smart ammunition will find its target, or recently the pager explosion in Lebanon, you know, whether the pagers you bought with your money will explode in your pocket, etc. So to remove all of these questions and dependencies, we can start from human resources and go all the way to the end product with solutions that we trust. Yes, friendly countries, allied countries are important, but also we all need to create these alternatives with our companies. In a critical raw material or component or engineering capacity, even having a company go down to a single raw material would be a success for us. They would support us and we could produce together. The success in Turkey also has this collaborative work behind it. And as Turkish people, we have a high intelligence individually. I go to Chinese factories, and every 20 meters they hand me over to some new person, so they explain everything to me. If you were to come to our company, one person could take care of all of that. So we have high individual intelligence, but not so much collective intelligence. But I think we're surpassing these problems. And when we look at the platforms in the Turkish defense industry, there can be 7, 8 subcontractors which have 300 companies below them and thousands of people. We've done this, and to do more, we need to keep working diligently. And at this point, we need to use our resources well. And our sister companies and affiliate companies created the core of this, but our presidency of defense industry, under the presidency of industrialization, we expanded this with some ecosystems and certification. But I can recommend the book, The Hidden History of Industrialization, written by an economist born in South Korea. There it says that the standards are a barrier created by huge countries to prevent smaller countries from leveling themselves. Now, of course, we're going to have the highest standards in whatever we do, but we also need to do this to the level we can domestically to reduce certification processes and to bring everything to a more understandable level. And we need to write our own standards right now. So in this sense, we have great potential in the country and abroad as well. In a lot of countries, universities, a lot of projects, we've seen that the most complex platforms are created by Turks, and we also brought back a lot of knowledge to our country. So in this sense, I believe we will do some more great work as we develop our collective approach and mentality, and it gives me great honor to be able to witness this. Thank you. Thank you, General Manager. Rector, please go ahead. Thank you. Now, technical risks. I'm looking at it from a narrow window. So Aselsan couldn't get lithium carbonate, cobalt, nickel. We don't have supply. What could be a solution? So when we consider that, our general manager, yes, from the borax mineral, etc., somehow we get lithium carbonate, but this we have. What else? Zorlu Holding, for example, the Zorlu Group, has a facility in Manisa, the Elementajik facility for hydroxide and cobalt lyroxide, and they did a lot of exports, and I think recently, due to an increase in sulfuric acid prices, they paused, but still they're ongoing. So, in a general sense, we have the resources to meet Aspilsan's need, although it may be difficult or expensive. But we need to draw up a roadmap. We need to develop the know-how and move from the mineral to meeting Aspilsan's needs and establish a pilot facility to overcome these obstacles. And in the case of a crisis or need, we can move on to that critical phase and at least carry out production to meet our needs. I think this is necessary. Similarly, this also applies for tea. If they can't get superalloys, what are they going to do? What are they going to use in the engines? And related to this, in Turkey, there's nickel cobalt superalloys or tungsten mineral unprocessed, never processed. And the price has increased 5 times. We also have facilities in Antalya and Elazığ, but we only just send them as institutions. None of them are converted into super alloys or stainless steel. So at least, leaving aside cost effectiveness at a time of crisis like what we're experiencing with germanium right now, of course universities should working on what alternatives could be to germanium, but that's not easy. When we meet with sectoral heads, they say that it's really hard. So whatever local resources we have right now, we need pilot facilities that can meet the needs of contractors. We need to do whatever we need, and I think there is some convolution here. Similar work is being done by different parties. Our suggestion here is to first draw up an inventory of critical raw materials. So whatever is critical for us, we need to create an inventory of them, identify them, and then the Ministry of Industry and Technology and Energy and Resources, the main contractors like TÜSAŞ, Aspilsan, whoever. TÜBİTAK definitely needs to be involved in this, and TÜBİTAK has high competence here. And in universities, as Mr. Öztürk said, the people we need are in universities. They're the people who can resolve this. We need to draw up a roadmap. And I think we need to pay attention to these. And we are running low on time. Anyway, the main contractors sometimes force the hands of subcontractors too much. They can't profit, they go bankrupt, have problems, and they exit that field. And we also need to support them, I think. I know it from Sivas and from other places that it's very valuable to keep them standing. From optics, I've seen in a lot of technoparks, they're very successful, they've achieved some things, but they're barely able to hold on. And they're always concerned about going bankrupt. I always tell these although I always tell people that we need to support these startups, but critical raw materials integration mechanisms definitely need to be the driving force behind all of this and coordinate all of this to define the tasks for each institution or organization, etc. I think this is how we need to go about this. This was a summary. Sorry, I went over our time limit a little bit. Salutations. Thank you very much, Professor. Matter of fact, to briefly summarize what we've talked about, a strong academy, digitalization and artificial intelligence support. These are two very critical emphases. A common roadmap is also something we see to be critical, and we shouldn't leave this just to universities or research centers or the platforms. We need to do this all together. It's a common need cluster, and we need to identify common need clusters and a common roadmap. And this has been a great panel, and we saw SSP as a joint processing material. We thank all of our panelists. If you have any questions before we end the panel, we would like to receive them. We still have 6 minutes left. It would appear that there are no questions. Thank you very much for your attention, and we also thank each and every one of our panelists for their contributions to this visionary discussion. And also, we offer our gratitude to our participants for all of their attention. Thank you. Yes, we had very valuable panelists, professors with us. They shared their knowledge, experience, and wealth with us. So we thank them very much. We also thank our moderator very much. And to commemorate this great day, we would like to offer you some souvenirs. I would first like to begin with Ms. Sudia Kalinch, our moderator, and she can hand it to our panelists.